Hello. Have you had fun? Have you learned how to program? A little bit with the Raspberries. So I have a lot of Raspberries at home also, and I use them for all sort of things. So I will try to explain a little bit about myself and my career today, my journey from a little kid up until today, what I learned and where I've been going in different companies and so on. A lot of it had to do with IT and computing and programming and all that, and I hope it's interesting for you to hear about. So, first of all, that is me. I was 1 year old and didn't have a clue about anything on science, technology, etc. But very quickly after this photo, I started to get into experiments. I grew up in Denmark and I spent most of my life in Denmark. After a couple of years, I moved to Spain. And the last 5 years, I've been living here in the Bay Area. So first of all, when I was a kid, I grew up in this place. In the middle of the countryside in Denmark, a lot of green, a lot of cows and cats, etc. And most of my time I was playing around with this thing over here. That was my big hobby, a dirt bike. So everything in my day was about motorcycles, etc. I also had a little bit of interest in things that could fly, primarily because my dad was a pilot. So when I was a kid, I wanted to be a pilot also, or an astronaut. And as you probably know by now, I didn't get to do any of those things. But I had a lot of interest in flying machines, and I actually spent a lot of hours flying with my dad in this one. It's called the Piper Cup. But this area, that was my playground the first almost 18 years of my life. Doing a lot of experiments, just playing around as every other kid. Moving on a little bit, so when I got to about 10 years old, we started to have classes in school regarding chemistry and physics and so on. And I started to have some interest in hot air balloons, and I wanted to build my own. So I basically started to read about it. At that time, internet didn't exist, so I had to go to the library, get some books, and basically read up on how do hot air balloons work, what kind of material do you use to build them. And I ended up building my own. It was about 30 foot tall, so quite a big one. And my interest was actually to lift something up. Not myself at that time, but I wanted it to be able to carry some cargo from one place to another. And I managed to do that, and I also managed to run into some issues with neighbors and so on, because they thought it was a little bit dangerous what I was doing. So that experiment kind of stopped after a couple of tries, but it was fun while it lasted. This name here, this is actually the people in France who made the initial attempt, which is the photo here, or actually it's a drawing. So they started this whole hot air balloon topic. Then I moved on. I moved on to rockets. So my uncle, he knew how to build rockets and many other things. So he taught me how to build my own rockets. That was actually quite fun. I won't recommend it, at least not unless you're doing it with someone who knows what they're doing, because they can blow up. But I built my own rockets, and some of them blew up, some of them worked, and it was quite fun. And I had some smaller incidents about it. So at one time, I was blending this up here, flash powder, and I was not preparing it properly. I didn't read the instructions properly. So it actually blew up in my face, and I lost my hair up here a little bit. And after that, my parents told me, that's it, stop doing that. But it was fun. Obviously, given that my dad was a pilot, I wanted to get into the air. So when I was about 14 years old, I started to build my own wing. Not a complete plane, but more something like this. This is not me, by the way. But I built my own wing. I studied all the topics about aerodynamics, how you need to shape the wing to make sure it has lift, how you need to steer, how big it has to be to carry you, etc. And I actually got to the point that it could carry me. So I was running down the hills at home, and I managed to get it to lift off and take me for about, 20, 30 meters or something like that. And then I crashed. And I almost broke my hand, and I had bruises all over the place. So again, my parents told me, that's not how it's supposed to be. You got to find something different to do. So I kind of stopped the whole thing about going into the air and moved on a little bit. So my parents, they bought me a computer. You may not have seen this specific model here in the museum, but there will be one downstairs called ZX80. It's the same thing, just different box and so on. That was my first computer. And at that time, you couldn't buy computer games and so on. You had to program everything yourself in the programming language called BASIC, which is a little bit similar to what you tried today with Sonic Pi. Very easy to read. It's in English. You can kind of understand how the program works. I spent a lot of time programming this. I bought expansions. So this one was a color card. This was on a memory card. And little by little, I learned how to program a computer. I didn't have any classes. I just tried and tried and tried. One of my biggest issues with this one is I couldn't store my programs anywhere. I didn't have a printer to print them out, and the interface it had at the time, so today you can store it in a chip and it stays there. That didn't work on that one. So every time I turned it off, I lost everything. And I had to retype everything again next time I started. That was actually helpful. I learned a lot in programming because of that. Then I moved on, and this one you can actually see downstairs, the Commodore 64. And at the age I had this computer, most of my time went into gaming. That was kind of the big thing. So I didn't really spend much time programming the Commodore 64. I just spent all my time gaming, which was fun. I could have used the time better, but at that time, you don't think about that. Anyway, because of all this, I kind of had a big interest at my teenager years in computers. So I moved on to a bigger one, which is also downstairs, not exactly this model, but a previous one called Amiga 1000. It had way more capabilities. It had a mouse. It had multiple windows and so on, what is called multitasking. So with this one, I kind of got into programming again. I felt it was really cool to be able to create something that you could create a video, you could create moving computer graphics and so on, things that were not that easy on the Commodore 64. And I learned new languages. So on the old initial computer, it was BASIC, but with the Amiga, I learned a programming language called assembler, which is very deep into the computer. You have to know a lot about the chipsets and so on. But I also learned a programming language called C++, which was actually invented by a fellow Dane, a guy called Bjarne Torstrup. There's a photo of him outside here. So he's the inventor of that programming language. So moving on a little bit, I got into actually developing my first software. So I made my first program, which is the one you can see up here. Very simple thing that was developed on the operating system called MS-DOS. Very old school, didn't have any mouse or anything like you control it. But that was the platform I had at the time. And what this software does is it takes a sound signal and analyzes how the sound signal looks like in the computer. And you can see if the stereo balance is correct and stuff like that. So that was quite fun, and it took an incredible amount of time to develop it because I didn't know exactly how to do it, especially the graphics. At that time, it was cool to have 3D buttons and so on. But I had to figure out how to make that myself, how the shadows work and stuff like that. I also had an interest at that time in music, so I actually started to make music on my computer. Not with Sonic Pi, but some similar software at that time. And I got to the point where I actually released my first track on a CD. So I was really proud at that time. And I got into what is called Unix. So a lot of the big machines you can see downstairs, they run an operating system called Unix. And actually, if you have a MacBook at home, it also runs Unix. If you have an Android phone from Google, it runs kind of a flavor of Unix also. So Unix is all over the place. The Raspberry Pis you were programming earlier, they run a Unix flavor also. I got into Unix, and I got my first job after studying computer science. And I started to work for this company called Digital. That was kind of the #1 company at the time in Denmark if you wanted to work with big enterprise computers. And I started to develop even more software. Initially on Windows, that was not a big success for me. So I kind of moved back to Unix and spent a lot of time developing solutions on Unix systems, implementing solutions for customers in Denmark. With actually some of the machines you've seen downstairs. So there's a lot of machines downstairs called PDP from Digital. I worked on the next generation. So I didn't get really to work that much on PDP. I'm too young for that. But I worked on the next generation. Moving on a little bit, I got into more advanced programming. By learning what I've started here, I got into enterprise software development. So I worked at a customer in Spain who said, we need something that can monitor our systems. And there's nothing in the market that either does what we want or comes at a price we're willing to pay. So they asked me, can you develop something with open source tools? So basically software and solutions you can download from the internet and use for free. So I came up with this tool, which is basically a tool that collects statistics from all the different computers and tells you how things are going. If they're overloaded, if they're available, how much memory is being used, and so on. And then I kind of changed a little bit my career. So up until then, I've been a total geek, focused on programming, on assembling computers, putting electronic circuits together, and so on. And I felt I'd kind of hit the end of the road on that in the company I worked for. I needed a change. And at the same time, I also became a dad for the first time. And my wife actually told me that all that stuff I had at home was not so welcome. We needed to put our baby into that room. So having all these computers and keyboards and so on, it didn't mix very well with being a dad. So I got rid of all that. I donated it to actually a computer museum group in Spain. And they're now using some of that equipment for education in Madrid. And I moved into a different role in my company. So I moved from a pure IT geek kind of person into a pharmaceutical company and started in my first job as a manager of people, which is this company called Roche, which is the mother company of where I work today. That completely changed my approach to IT. So up until then, everything had been about computers and memory and hard drives and so on. And now suddenly the focus of the company I was working for was no longer IT as a primary thing. It was developing medicine for people. And everything we've been working on in the company is around DNA, which is basically how we are built, human beings are built. And that completely changed my approach to IT. So now I could no longer go to the business and say, well, I have this cool new computer. I had to start understanding what do they need from us? What do they need from IT? How can we help them? And they would not understand all the IT terms I was used to in my previous work. And my primary job in this company has initially been buying storage. So there you can actually see my son Eric, and behind him a lot of storage. That was the thing I did, buying hard drives, more and more. And then connecting the hard drives to very strange installations that they were using in the lab where they would analyze DNA, sequence DNA, and so on, and try to take that information and put it on a computer to be able to run studies on top of it. So, have any of you heard about DNA before? Okay. Do any of you know what it stands for? It's a very long name. Very good. Very good. It's a very difficult name, yeah. So basically, everything we do where I work today is about that. I'm still in IT. I'm not an expert in any of all that, but I have to support the IT for all the researchers in our company. What they do is they analyze the DNA of the human being, and they have many different methods of doing that, and some of them you actually may be aware of. So a lot of the sort of well-known companies, Ancestry and Illumina, 23andMe, are companies from around here. They use DNA to sell services. So you can go into this webpage of Ancestry and you can submit a test to them, and they can tell you how you're related to other people. You can do the same with 23andMe. They can actually tell you if you're more prone to have a specific disease or not. We are using that kind of information also in Genentech to try and figure out how can we cure cancer, how can we cure specific diseases by analyzing the DNA of people with the disease, people without the disease, different animals, and try to compare and figure out what makes sense. The problem we have is that analyzing this generates a lot of data. So typically, the human DNA for one person is about 700 megabytes. So a music CD, more or less. But the way we analyze it, it's not sort of you get everything in one. You have to make multiple samples to have enough data to actually use it. So typically, we end up with 200 gigabytes. And if you start to say, well, I need that for 1,000 people or 10,000 people, it started to grow. And as an example, this study here that you can actually download yourself for about 1,700 people occupies 200 terabytes. And in our company right now, we have about 150 petabytes. So 1,024 of terabytes. We have 150 on those, and they occupy a whole data center. And it's very expensive, and it uses a lot of power. So just running this infrastructure in our company, it takes about 800 kilowatt. So more or less the same electricity as a small city. And we have to use all this information to be able to develop the medicine we are working on by basically running computer programs on top of the information to try and figure out what is causing a disease. Why is cancer developing in this patient and not in that? Any one of you know why this company is called 23andMe? Exactly. And do you know what's the difference between 22 and 23? Anyone? So the first 22 chromosomes are equal on all people. The last one, the 23rd, is whether you're a boy or a girl. And that's the kind of information we try to analyze. So this diagram here is actually what we are working on right now in a division of the company called Genia. They're using a new method of analyzing DNA. The problem we have had with DNA in the past is that it takes quite a long time to analyze. So it's slow, and it costs a lot of money. And they're trying to see if they can run this in parallel to speed it up and make it cheaper. And they're using this system, it's called a nanopore, where they can do the analysis in parallel for many different DNA structures at the same time. Let's see if I can get on. So, I suppose all of you have, at one point in time in your life, done a blood test. So you go to the doctor, they make a sample, and they send it somewhere, and then you get the results later. Anyone tried that? All of you? So the funny thing is, most likely that blood sample went into that machine. So this machine up here is called a Kobus 8000. That's a machine we manufacture. There are other companies doing that also, but we have one of them. So typically, when you go to the doctor to make the blood sample, they send this blood sample to a hospital or a specific company doing blood analysis. They put it in to this machine, and this is actually a big computer and a robot at the same time. And it'll automatically test your blood and test for all different diseases and symptoms and viruses and so on. And then it'll output an analysis report telling whether there's a problem or not with the blood. And it's fully automatic. You don't have to do anything except put in the blood samples at the beginning, and then the output comes out. And right now we're working on a smaller version. So the future is this machine, which is, it looks big here, but it's actually not bigger than this. That one you can put directly in the doctor's office so they can test for certain things while you're there, rather than have to send it in and wait for a week or two. So that's something we're working on right now. And at the same time, this machine generates equal information to a DNA sequencer. So we are trying to take the output from this one when we do blood analysis and combine with the studies we do on DNA to figure out if there is relationship between what we see in the blood and what we see in the DNA structure. And to do that, we need computers, we need IT, we need software, we need programmers. So some of the things I wanted to give you as an observation about what I've learned during my career in the different jobs I've had, being initially a computer geek and now being more a people manager, is stay curious. The one thing I feel has taught me the most is I never said, I'm never going to learn this. I'm not smart enough. I've always had the mindset that if I study enough, if I seek the information where it's available in the library, in YouTube, whatever, I'll get it. Maybe not the first time, maybe not the second time, but I'll get to it sooner or later. I may not be the best, but I'll be good enough. And I've had many situations like that. So I've done a lot of experiments, most of them failed, and I learned, and I did it again and again and again. And I was not the brightest kid in class, not even close. I learned fairly quickly that, for example, math, that was not my best thing. But I studied again and again, and I tried, experimented. And little by little, I got to a level where people considered me to be a resource, someone they could count on, someone they could go to with a problem and expect a solution. So the curiosity has really helped me. And that's something I would like to transmit to you, that stay curious. If there's something you would like to learn something about, don't feel afraid. Go ahead. So a good example is, many of you probably know Michael Jordan. So, basketball player. He didn't make it to the high school team. He actually failed when he tried to get into the high school team. But he was so convinced that he could make it, that he was a good player, that he went back and trained more and more. And the next year when he tried to get in, he got in. And as all of you know, he became one of the biggest stars in basketball. So he had that mindset, the grow mindset as they call it, that he didn't limit himself and say, well, I can't get better. He had the mindset of course I can get it, I just need to train more. So I've tried to do the same. Where I don't know something, an area I just don't know about and I feel I need to know, I study. I seek the information. I go and ask the people who know about it, and then little by little I get to the level where I feel comfortable and can add value. So have that kind of mindset. Today with the programming you've done with the Sonic Pi, if there's something you didn't understand, go back and ask, find someone, find something in internet, and you'll get to know it. And that's basically what I had.
All right. Big round of applause for Jesper. Thank you so much. Awesome. Well, we are going to open it up to questions. So you guys can ask anything you want to know from Jesper. And Jill has a microphone, so please raise your hand if you have a question, and we're going to get started. You can ask anything you want. So who wants to go first? Go ahead and raise your hand, and we'll start. And volunteers and chaperones can also ask questions. That's totally okay. All right. If everybody's shy, I'm going to ask a question. Nobody has questions? Everybody too shy? All right, I'll ask a question. My question is, I know that a lot of you do activities. Who here plays a sport? Yeah, okay. Who is in a club at school? Yeah. So I know that, and you also all have homework, right? Everybody would raise their hand if I asked who has homework. Okay. So it's really hard when you want to do all these things, and you have a lot of different interests, right? And a lot of things pulling on your time. So I know that in your talk, you talked about how when you first became a dad, you had to get rid of some of your supplies. So I just was wondering if you could talk about how you decide what to focus on, because you seem like you're interested in a lot of different things. So how you picked when you had more of those time constraints.
I would say it was also a combination of when I transitioned from being a sort of a technical expert to becoming a manager. I had to make a choice. What's important in life? And I realized fairly quickly that I could not continue to do everything. If I did, I would be stressed and not get enough sleep and all that. So I got to the point where I said, well, it's okay not to be the best. It's okay to be just okay. That allowed me to free up enough time to be able to focus on the things I needed to focus on. And I cut many things away. I used to spend many nights programming, testing things, electronics, and so on. And I still have that interest. I just don't spend as much time anymore as I did in the past. And you have to learn to adapt to where you are in your life. And when you're young and don't have all these things around you, kids, etc., you can kind of allow yourself to spend more time of this. But as things change and you get more responsibilities and so on, you have to cut things away. If you try to do everything, it won't work, and you'll get stressed.
That sounds like good advice for time management. I think Jill has a question over here.
Yeah.
Was it hard to give your technology away?
Sorry?
Was it hard to give your technology away?
My wife will probably say yes, it was really hard. It took a couple of discussions to ditch all the technology I had because I'd been collecting all these computers for years, and I really enjoyed working with it. I will say, now that I live here in California and I have a garage, I've actually built a rack again, so I have a rack at home with a lot of computers and so on. I don't spend nearly as much time as I used to do on it, but I still have my own small playground in my garage, and whenever I need to test something, so for example, nowadays I work more in the network space than pure computers, and when there's something where I feel, hey, I don't know enough about this, I go to my garage and I test something to see how it works. So I've kind of recovered a little bit on the technology side. I still have quite a few devices. So as an example, I have, I think, more than 10 Raspberries at home, doing all sort of things, running web servers, and yeah, a little bit of everything.
Out of all of the things you did when you were younger, what was the most enjoyable for you to do?
I think the thing that I liked the most was developing my first program from scratch to having something that I could actually sell or give to other people. The whole process, so not only just programming it, but writing documentation, making sure that it was packaged so I could distribute it and allow someone else to install it. It was very hard work, but getting to that point where I could say, well, I actually made something. I made a product, and now I can give it to someone else. That was a real joy for me. And to be honest, when I started, I didn't have a clue. I'd never done it before. So I had some hard lessons where I tried something and it failed, and I had to more or less ditch everything and start all over again. But from that, I learned. I learned how to deliver packages on a Unix system. I learned how to write documentation that someone else can understand. Usually I would write something that only I would understand. So that process was very good for me.
All right, awesome. We have a question here.
Hi. How old is your child now, and where is he compared to where you were at his age?
So I have two kids, 14-year-old and 8-year-old. I would say they're not that different. One of them is sitting over there. They're not that different from me. At that age, most kids just play around and don't know quite what they want to do. And I was in the same situation. I grew up in a different environment. So as you saw from one of the first photos, I grew up in the countryside. My nearest neighbor was almost a mile away. So I was alone for quite a while every day, where I had to just invent things I could play with. Today it's different. Most people, at least here where we live, they have neighbors, they can go out and play with their friends and so on. And they have so much more IT around them. iPhones, iPads, Android telephones, Xbox, etc. All that kind of stuff didn't exist when I grew up. So a lot of the things today, kids take IT for granted. They just know. They just know how things work. At that time, I had to learn a lot of this. You couldn't buy those kind of things at the time. So I wouldn't say my kids are different from me in that sense. I was maybe a little bit more experimental, but that was probably just driven by the fact that I grew up where I grew up and there was not much else to do. What I can say is the fact that my parents bought me a computer when I was fairly young, that made a big impact on me. And also I had a friend of my dad who used to work at a bank. He took all the old calculators and IT components from the bank that they didn't use anymore, and he gave it to me because he knew that I would like to do electronics and stuff like that. So I spent a lot of time taking apart calculators, big calculators, and figuring out how they worked and how they didn't work and try to see if I could repair them. And doing that, I learned a lot. And to be honest, when I did that when I was a teenager, I didn't know anything about the electronic side of it, so why they didn't work. I learned simply by doing, and okay, sometimes it'll blow up a transistor, and I was like, okay, that was the wrong thing to do. And then I would try something else. So a lot of my learnings as a kid was by trying. I didn't always study the whole theory and learn the whole theory first and then did it. I usually did it the reverse. I did it first and something broke, and then I had to study why did it break, to not run into the same situation again. With my kids, so I'm not trying to push them that they have to do the same as me. I want my kids to be open. They should pick what they feel comfortable with, what they have interest in. If it's IT, I can help them. If it's basketball, maybe not as much. My older kid, Frank, he can beat me in basketball easily. But I want them to pick themselves, and I will try to help them with what I can.
All right, awesome. We have another question here.
What is the most important thing you've ever done in your career?
I think the most important thing is kind of coming back to the question before about time management. So realizing that you can't do everything, that you have to prioritize, and the things you really want to do, you have to focus on. That took some time for me, especially when I transitioned from being a technical person to becoming a manager. Initially, when I started as a manager, I still wanted to be the technical expert, and I couldn't do both. If I wanted to become a good manager, I had to learn new skills. So I had to give up something, and I think that's in general my most important learned lesson in my career, knowing what to give up, knowing what to focus on, because you can't do everything.
All right, those are awesome. Is any other last questions? Oh, we have another question. All right.
What is the epic fail?
Sorry, I didn't get.
An epic fail, something that you did and it was really
Oh,
bad.
oh, I have so many.
Your biggest fail, he says. What's the biggest mistake?
I have quite a few. So I think that the biggest one I did, luckily it didn't have so big an impact, but it could have had. So when I was working at Digital in Denmark, I spent too many hours in the data center working on big servers and stuff like that. And I was kind of sleepy doing a big maintenance over a weekend where I had to upgrade some systems and copy data from one place to another and so on. And then I had a system crash in the middle of my maintenance. And I felt, well, I can fix that. But without any planning, I just went in thinking, well, I know how to do this, etc. But because I was sleepy, when I had to restore the system from the backup, I forgot that the backup server I was restoring from was by default putting the restore into itself and not to the server that had crashed. So I ended up restoring the server that had crashed into the backup server. And I didn't realize that until everything had finished. And then suddenly my manager called me and said, hey, I'm getting these events. So we had a phone alert system. I'm getting these events saying that the machine called Telus thinks it's called Pegasus. Why is that? And he had already figured out what went wrong, but he didn't tell me. He wanted me to figure out myself. And I didn't realize it at the time. So he just let it as, because there was no big impact, so he didn't do anything about it. And the next morning when I came into the office, he asked me and said, hey, Jesper, did you do a restore yesterday? I said, yeah. What server did you restore? I said, I restored Pegasus. I said, okay, from what server did you do that? Well, I did that from Telus because that's the backup server. I said, okay, could you log into Telus and check that everything is okay? And I logged into Telus and it told that it was called Pegasus. And then I realized like, oh, I messed up. And obviously he asked me to fix it, so I had to do another maintenance the weekend after and make everything good again. So I think that's the biggest thing I have done in my career where I messed up. Definitely not the only thing. I've made a lot of mistakes, and I learned from most of them.
All right, great answers. Any other questions? Oh, there's a question in the back. Sure.
Hello, my
Hi.
name is Giselle Beltran, and I have a question concerning your mistakes, because I have this philosophy where I believe we can learn from personal experience or experience from others. And you mentioned that you developed your own software, and that was something that brought like huge accomplishment and fulfillment in your life. And I'm wondering, what are some mistakes, or like what are some advices, I should say, based off of your mistakes that you could give to someone that would like to go within those steps as well in creating something on their own?
Yeah. So I'm not sure I heard the whole question, but I think it was about the learning lessons about developing a product. What I can say about that is I never thought about being a software developer, developing my own product. I never had that in mind when I started. It kind of grew out of itself that I was playing around with things at work, and it got to the point where actually a colleague of mine said, hey, Jesper, you should sell this. You should develop it and make it a product. You can make money out of this. And I never thought about that. But then I started the process by thinking, well, actually, it's kind of useful, and people like it at the company. Maybe someone else can use it. And then I started to study, so how do you go about this? And I think what I can give as advice to people in general is that usually what prevents you from getting to a point where you develop something that someone else will be interested in buying or using, the biggest prohibitor is yourself. Usually you're the one telling yourself that, nah, it's not good enough, nah, you don't know how to do it, it'll never succeed. So having the mindset of thinking that, of course I can make this happen. Even if you don't have all the skills, you can gain those skills. And I definitely didn't have all the skills in the things I worked on, but I learned. And I still try to do that. So as an example, last year I wanted to do something in metalworks, but I didn't know how to weld. So I signed up together with my oldest son for a welding course. We learned to weld. He learned better than I did, but both of us got out of the class knowing how to do that. So having the mindset that you can learn everything if you try, that's important. And then you can get to the point where you can actually develop a product yourself from start to end.